Okay, welcome back. And now we're going to do an example. And what we're going to do is we're going to use the definition of the definite integral to evaluate this integral. Okay? So what's the definition? Well, the definition says that we're going to take the limit as n approaches infinity of f of x sub I star times delta x. Oops, forgot the sum. So summation of I equals 1 to n of f of x sub I star delta x. Okay, so now that's the definition. Now we just need to find the Riemann sum. Okay? So let's figure out what the Riemann sum looks like. Okay, so and they also want us to use the right end point approximation. Okay? So they want us to use the right endpoint approximation that's what we're going to do. So let's go over here and do some scratch work. So first of all, we got to find delta x. Delta x is again b minus a over n. Okay. Okay, so what do we need to do here is let's think through this. So our intervals, remember our intervals are going to be x sub I minus 1 to x sub I, right? So since we're using the right endpoint approximation, we're going to be using x sub I, right? So that's what we're going to be using our Riemann sum. Okay, now, since a and b are given, well, we know that this is going to be equal to 2 minus 0, so it's going to be 2 over n is going to be delta x. Okay? Okay, so now, how are we going to find the partition? So we need to find the regular partition, right? So, since this is delta x, and we know that x sub I is equal to x sub 0 plus I times, I times delta x, right? And so this is going to be x sub 0, which in this case is 0, right? Because x sub 0 is a. So this is going to be 0 plus I times 2 over n. So delta I is going to equal, well, just that. It's going to be 2i over n. Okay? Okay, so now, those are going to be the values of our right endpoints that we're going to use. Okay, based on what n is. Okay? So, the function value at the right endpoint is going to be given by what? Well, let's find f of x. So f of x sub I is going to be given by what? this function, x squared. So that means it's going to be 2 times I over n quantity squared, right? And so that's going to give us 4i squared over n squared. Okay, so now we've got the value of our function f of xi. Okay, we've got delta x, and so now let's put it together with the summation. So now, this is going to equal the limit as n approaches infinity of the summation of I equals 1 to n of this 4i squared over n squared times delta x, which is 2 over n. Okay. And now I'm going to start over here just to give myself some more room. So now that's going to equal the limit as n approaches infinity of the summation for I equals 1 to n. And so this simplifies, so again, so this is going to give us an 8i squared over n cubed, right? But now look at here. This summation is based on the index I. So the only thing, so anything that's not dependent on the index, we can treat as a constant, right? So we can pull this out and write this as the limit as n approaches infinity of what? Of 8 over n cubed, right? So n is dependent on this, so we can put this here, okay? And then it's times the summation as I equals 1 to n of I. Well, we know this formula for this summation, right? For n consecutive integers. So what does that give us? Let's start down here. So this is going to give us the limit as n approaches infinity of 8 over n cubed. Now, what does this give us? Well, that is just n times n plus 1 over 2, right? That's the formula for summing up n consecutive integers from 1 to n. Hold on a second. Oh, I dropped, I'm sorry. It's I squared, not I. I dropped my exponent. Sorry. So it can't, so it's not that. That's for I, sorry. For I squared, what is it? For I squared, it's n times n plus 1 times 2n plus 1 over 6. Okay, that's correct. Sorry, so just be careful not to drop your exponent. When I factored this out, I dropped my exponent. Okay, so now we're going to simplify this. So this is going to be the limit as n approaches infinity. And what do we got? We got 8 over n cubed. Now let's simplify this. This is going to become 2n squared, so it's going to be 2n cubed. And then n plus 2n, which is going to be 3n. So I'm going to get 3n squared. And then I get 1, so that's going to be plus n over 6. Okay? Now here, the 8 and the 6 can be reduced, right? They're both divisible by 2, so that's going to be 4/3, okay? I can simplify this too because I can break this up. So let me rewrite this so you guys can see it better. So this is going to be the limit as n approaches infinity. So now what I'm going to do is I'm going to write this as 4/3 times (2n cubed) plus 3n squared plus n over n cubed. Okay? Okay, so now let's simplify it further. So it's going to be a limit as n approaches infinity, 4/3 times, and then this is going to become 2 plus 2 plus 3 over n plus 1 over n squared, right? Now, look what happens. This is a constant, doesn't depend on the limit, doesn't depend on n, so we can pull that out. So we can use all of the limit laws that we learned. This is going to be a constant, so that's going to stay the same. Right? So let's just go one more step. So this is going to be 4/3 times the limit as n approaches infinity of what? 2 plus 3 over n plus 1 over n squared. Now notice, as n goes to infinity, this fraction is going to 0, this fraction is going to 0, so guess what? You're just going to end up with 2. And so guess what? The answer is going to be 4/3 times 2, or 8/3. And so the definite integral is evaluated and gives us the answer. So the answer to this integral, this definite integral, is 8/3. And that's it. So again, take your time, walk through it step by step, and make sure that you're understanding what to do. And again, practice. Once you start practicing and then you get the hang of it and you start recognizing things, you can go faster, you can combine steps. But my advice is always start slow, and then the speed will come later. Have a great day.